Hi students, welcome to this video session. My name is Samuel Chukwuemeka. In this video session, we shall study rational numbers. We shall write whole numbers as rational numbers, write mixed numbers as rational numbers, determine if a given rational number is a repeating decimal, determine if a given rational number is a terminating decimal, write a fraction as a decimal, write a mixed number as a decimal, write terminating decimals as fractions, order rational numbers from least to greatest, order rational numbers from greatest to least. Then we shall solve real-world problems involving rational numbers. This is the first video of a 2-video series on rational numbers. Let's get started. What are the vocabulary words? Natural number, whole number, fraction, numerator, denominator, proper fraction, improper fraction, rational number, integer, mixed number, decimal, terminating decimal, repeating decimal, non-repeating decimal, irrational number, real number, and complex number. It's a whole lot, but if you can see, the ones that we will take note of in this video are the ones with these bullets, the one that has these bullets. So if we look at all the ones with these bullets, those are our main concern. Now these other ones, we cannot talk about these ones with the bullets without mentioning the ones with the circular bullets. So that is why we listed them as well. Alright, what are the definitions? We know that a natural number is any positive integer. It does not include 0. It does not include the negative integers. It is just a positive integer. And it is not a fraction. It is not a decimal. Natural numbers are also called counting numbers. You can count them like 1, 2, 3, 4, 5, and so on. Now, in mathematics, anytime you see this, it means natural number. In mathematics, anytime you see this, it means natural number. Anytime you see n, uppercase n, natural numbers are represented by uppercase n. The next on our list is the whole number. The whole number is any non-negative integer. Now, can you tell the difference between positive integer and then non-negative integer? If you look at positive integer, it does not include 0. It includes all the positive integers, but it does not include 0. When we talk of non-negative integer, it includes 0 and the positive integers. So we can say that the whole number is 0 and the natural numbers. Okay? 0 and the natural numbers are the whole numbers. Remember, it does not include negative integers. It is just non-negative, which means it is 0 and positive. A whole number is not a fraction and it's not a decimal. In mathematics, whole numbers are denoted by uppercase W. uppercase W, denotes whole numbers. The next on our list is a fraction. A fraction is simply defined as a part of a whole. It is the part of something out of a whole thing. It is also seen as a ratio or quotient. The numerator is the top of the fraction, the top part of the fraction, which is the part, and the denominator is the whole or the bottom of the fraction. A proper fraction is a fraction whose numerator is less than the denominator. So if we have something like 2 out of 5, for instance, we see that the numerator is 2 and the denominator is 5. So this means this is a proper fraction. An improper fraction is a fraction whose numerator is greater than or equal to the denominator. So if we have something like 5 over 2, 5 out of 2, the numerator is 5 and the denominator is 2, we say that this is an improper fraction. If we also have something like 2 out of 2, if the numerator is also equal to the denominator, we can also call this an improper fraction. And our main concern here, our main topic here is the rational number. A rational number is any number that can be written as a ratio of 2 integers. Now the key word here is written as a ratio of 2 integers. It can be written as, okay? Now it must not be a ratio the first time you say it, but you can write it as a ratio of 2 integers, okay? Or you can say as a fraction, provided the denominator is not equal to 0. For instance, if we have the 2 out of 5, this is a fraction of 2 integers, or this is a ratio of 2 integers. 2 is an integer, 5 is an integer. So this is also a rational number. If you have something like 7, now 7, you will see that 7 is a whole number. It is also a natural number. But can you write 7 as a ratio of 2 integers? Can you do that? And if your answer is yes, because 7 means 7 over 1. 7 divided by 1. So if you look at this, 7 here is an integer, 1 here is an integer. That means 7 is also a rational number. So a rational number is a number that can be written as, it can be expressed as a ratio of 2 integers. We will soon get to what we know as integers, okay? Now, one condition here is that the denominator should not be equal to 0. Assuming you see a fraction like this, 5 over 0. Now, if you try to do this in your calculator, if you try to do 5 divided by 0, you will see that it results in an error. Okay? It results in an error. So, you can't divide 5 by 0. You can't divide something by nothing. You cannot do that. Okay? So, in this case, this is not a rational number. Okay? Just note this. It's not a rational number. And then, in mathematics, we represent rational numbers by Q. Q. We represent rational numbers by Q. So 5 over 0 is not a rational number. It's not. Okay. The next on our list is an integer. An integer is any whole number or its opposite. Now, what do I mean by opposite? Like, opposite of 5 is negative 5. Opposite of 10 is negative 10. Opposite of 20 is negative 20. So, all the whole numbers, remember, our whole numbers are 0 and the positive numbers. So integer means the negative numbers, 0, and the positive numbers. Okay, it is not a fraction, it is not a decimal. It includes the whole numbers, 0, and then the negative values of those whole numbers, which we also call opposite. Opposite. Okay. In mathematics, we represent integer by the letter Z, uppercase Z. Okay, a mixed number is a combination of an integer and a proper fraction. Of course, if we have something like 2 whole number, 3 out of 5. The integer is the 2, and then the proper fraction is the 3 out of 5. Okay, this is a mixed number. A decimal is a linear array of digits that represent a real number, expressed in a decimal system with a decimal point, and in which every decimal place indicates a multiple of a negative power of 10. What do I mean by this? Of course, whenever you have something like a decimal point, like if you have maybe 0.4, you've seen a decimal point, so this is a decimal. And then this 4 means 4 times 10 to the negative 1. That is what it means. This 4 represents 4 times 10 to the negative 1. It is the first decimal place. If we have 2 decimal places, it will be something like 0.45. Okay, this is a 0.45. In this case, this is 2 decimal places. So this 4 represents 4 times 10 to the negative 1, and the 5 here represents 5 times 10 to the negative 2, and it continues that way. Yeah, that's what it means by the definition. Decimal can be terminating decimals or repeating decimals or non-repeating decimals. What is a terminating decimal? A terminating decimal is a decimal with a finite number of digits. It is also called an exact decimal. If we have 0.4, 0.45, 2.625, they are all exact decimals, terminating decimals. Now, what is a repeating decimal? It is a decimal in which one or more digits is repeated indefinitely in a pattern or sequence. A repeating decimal is also known as a recurring decimal. Sometimes you find decimals that keep going and going and going indefinitely. It is not finite. Remember, this is finite number for terminating decimals. Repeating decimals is infinite number. It's indefinite, it's infinite. Okay, we shall see examples as we go on. The next is the non-repeating decimal. Non-repeating decimal is a decimal in which there is no sequence of repeated digits indefinitely. So non-repeating decimals, is still infinite. It keeps going and going forever. Continuously. Ad infinitum. Ad infinitum means till infinity. But there is no sequence of repeated digits. The digits do not repeat. A non-repeating decimal is also known as a non-recurring decimal. Next on our list is an irrational number. Irrational number is a number that cannot be expressed as fraction, terminating decimal, or repeating decimal. In other words, when we compute them, they are non-repeating decimals. Most of the radicals are irrational numbers. Example, radicals. Yeah. But, that is not our main concern here. Now, irrational number, there is no standard representation of an irrational number, but sometimes you can, in some textbooks, you will see it as a Q with a bar. You know, Q is a rational number, and when you have a bar sign, it means that they are irrational numbers. Yeah. Some textbooks will also write it as the real numbers. We shall get to read in a moment. Real numbers minus the rational numbers. Some textbooks will have it this way. Okay. Next on our list is a real number. A real number is any rational or irrational number. So we see that all the numbers we've been using up to this point, up to this grade level, they are either rational numbers or irrational numbers. All those numbers are what we call real numbers. Okay, it includes all the numbers that can be found on the real number line. If you can remember the real number line, when you have the real number line, 0 separates the positive numbers from the negative numbers. To the right of 0, you have the positive numbers. And to the left of 0, you have the negative numbers. Okay, now in this real number line, this is known as the real number line, horizontal x-axis. In this real number line, you find every number that you've been using. You can find fraction like 1/2 is in between here, which is a fraction. 1.25 is gonna be around here. So you find a lot. You find 0.344578 is gonna be between 0, and 1. So all the numbers you see, they could be rational numbers, they could be irrational numbers. They are all classified as real numbers. Okay. And real numbers in mathematics, we denote real numbers by the letter R. Some textbooks will kind of write something by this, write it like this. Yeah. But if you write R, that's fine. Uppercase R. A complex number is a number that can be expressed in the form of A plus BI, where A and B are the real numbers and I is the imaginary number, equal to the square root of -1. When you go to college, you will learn about most probably you will learn about complex numbers. It is denoted by C. For our grade level, I am just mentioning it. You will also you will know more about it when you get to college. Now, let's do some examples, okay? Let's do some examples. Look at these numbers and tell whether they are whole numbers, proper fractions, improper fractions, rational numbers, integers, mixed numbers, terminating decimals, repeating decimals, or non-repeating decimals, or a combination of these. If you can see, I didn't mention all the numbers because this is basically on our objective. As I said in the beginning, we are more concerned about our objectives. Okay, so we want to know whether any of the numbers we shall see, whether they are, we want to classify them as any of these numbers or a combination of these numbers. Okay? So here are the numbers. These are the numbers that are coming up. Now, these are the numbers right here, and we shall look at them one at a time. Let's start with 30. So 30, what is 30? 30 is a whole number. Remember, you can count it. Whole numbers, you can count. Positive numbers that you can count, and also 0. 30, you can count it. So 30 is it's also a natural number, but I didn't write natural number here. Yeah, so it's a positive number that you can count, which makes it a natural number. But natural numbers are not listed in our objectives. We just mentioned it. So, but we're looking at the numbers here. So 30 is a whole number. It is also an integer. Remember, an integer includes the whole numbers and also the opposite of the whole numbers, which are the negative values of the whole numbers. Then it is also a rational number. Why is it a rational number? Because 30, you can write it as 30 over 1. That is how you write whole numbers as rational numbers. And remember, rational number, you can write it as A over B, where A and B are integers. Okay? So, and B is not equal to 0. In this case, our A is 30 and our B is 1. Remember, for rational numbers, you can write it as A over B. So in this case, A is 30, B is 1. And B is not equal to 0. So 30 is a rational number. The next one is 2 out of 5. 2 over 5. 2 over 5 we know is a proper fraction because the numerator is less than the denominator. 2 is less than 5. It is a rational number because it can be written as A over B. Okay? Where in this case A is 2 and B is 5. Now, what of 5 over 2? 5 over 2, what is it? It is an improper fraction because the numerator is greater than the denominator. 5 is greater than 2. 5 over 2 is also a rational number because it can be written as A over B. In this case, A is 5 and B is 2. What of the mixed number? 3 whole number, 2 over 5. Okay, this is a mixed number. 1 is a mixed number and it is also a rational number. Can you tell me why the mixed number is a rational number? Remember, rational number, you can express it as this. Remember, it could be expressed as this. Even if you say it at first sight, it probably does not look like this because the 3 here is an integer. You don't see any integer here. But can you express this as this? Yes, you can. Now, how can you? You can convert this mixed number to an improper fraction. And how do you do that? 5 times 3 is 15. 15 plus 2 is 17. So we have that 3 whole number, 2 over 5, is equal to 17 over 5. So you see, you have now expressed it as A over B, where A is 17 and B is 5. Because you have expressed it as such, the mixed number is a rational number. What of negative 30? What is it? It's an integer and it's also a rational number because negative 30, okay, you can still express it as what? Negative 30 over 1. You have expressed it as A over B. Now, A and B could be positive, A and B could be negative. It must not be positive, no. So we have positive rational numbers and negative rational numbers. In this case, negative 30 is a negative rational number, but it is a rational number. What of 0? This is interesting. 0 is a whole number. It is also an integer. It is also a rational number. Why is 0 a rational number? The same reason why 30 is a rational number. 0 means what? 0 divided by 1. And this is expressed as A over B. Now, remember, rational number is, you know, it could be the integers because 0 is also an integer, but b is not equal to 0. In this case, our b is 1, so we are good. Now a could be equal to 0, but b is not going to be equal to 0 because it will give you an error. You cannot divide something by nothing. Okay? Okay, let's come to decimals. What of 2.25? 2.25 is a decimal. What kind of decimal? It is a terminating decimal. It stops. Okay? Then it is also a rational number. Now, you might ask me, how is this a rational number? We shall explain this well in the next video. But if you look at 2.25, it is the same thing. It is the same thing as 225 divided by 100. Okay? We shall explain this in details in the second video. So, you see now, I still a over b. Okay? Yeah. So, it's still a rational number. We shall explain this in details in the second video. The next one, now 1.33333, you know, is how many threes? 1, 2, 3, 4, 5, 6, 7. Now, this means it keeps going, okay? It keeps going. So I can put 3 dots, meaning it keeps going. Now, this is a repeating decimal. It keeps repeating because what is repeating? The 3's are repeating, and it's also a rational number. The next one, 1.3 with a bar above the 3. Now, you know, this and this means the same thing. This thing you see like a bar is what we call the vinculum sign. The vinculum. The vinculum. If you know that 3 keeps repeating, you just put that vinculum above it. Yeah, it's the horizontal line you place above it. It's a repeating decimal and it's a rational number. If you look at this, 0.4527272727, what is repeating here? The 27 is a repeating decimal, is a rational number. Remember, I didn't say what is repeating here, 27. No. If you say 27, you are pronouncing it as a whole number. That is why, you know, let us learn the correct terminology. If it's 0.45, you pronounce it as 0.45 and not 0.45. Actually, you pronounce as 0.45 because it is a decimal. Now, if you pronounce as 0.45, it's as if you're pronouncing it as a whole number. Yeah. Okay, so this is a repeating decimal and a rational number. What we just saw can be written as this, whereby we have the vinculum sign, which tells us that this 27 is repeating. Okay, it is repeating decimal and it is a rational number. Now, if we have this decimal, 0.2375945627, it is a non-repeating decimal because it is not repeating. Okay, it is just a non-repeating decimal. And what? With the last one, pi is also a non-repeating decimal. Now, for these non-repeating decimals, you see, we didn't write rational number. Yeah, what are they now? They are irrational numbers. But remember, in our question, we didn't say irrational numbers are not in our objectives. We just mentioned it. Yeah. So, for this lesson, we want you to understand that all real numbers, all the numbers you've been using so far, okay, that they can be divided into rational and irrational numbers. And this video, we kind of concentrated on the rational numbers. Pi, this sign, if you ask me about it, you will still, when you do geometry, you will see this sign. It is a Greek alphabet. It is not an English alphabet. It's a Greek alphabet. Pi. Okay, and we shall see why it is a non-repeating decimal. We shall look at it in a moment, why it is a non-repeating decimal. So, if you go to your calculator in the computer, you can, if you go to your computer, you can type in calculator here to bring it up. Okay, when you go to your calculator, you have it in standard view. This is in standard view. You don't see pi here, right? You don't see the value of pi. Let's find the value of pi. So go to view, change it to scientific, and you will see pi. You will see pi right here. This is pi. And when you click on it, you see it's an irrational number. It keeps moving on infinitely or indefinitely, and the digits does not repeat. There's no pattern or sequence of repeating digits. Okay, please watch out for the next video of this lesson, where we shall deal more with the objectives. Okay, thank you so much for listening, students, and you have a great day.